Ooh, how can I make this more interesting?
Before we start,
Yes.
I hate to brag about this, but have you graded the quizzes in?
No, I haven't. I'm sorry.
Okay.
But again, at least the solutions are all listed.
Okay.
You guys, let's not answer the question yet. You just say something about my writing.
No.
What do you mean, no? Why not?
There's no theta or any angle
Yeah,
that you're
just no
taking
input
the
for
sine
my
of.
sine function. Technically speaking, this is not multiplication, that's functional composition. And if you're going to use integration by parts, the integrand has to be of the form u dv. It's got to be the case that the product of those two in their entirety is u dv. Something else that distinguishes this technique from substitution technique. When it comes to the substitution technique, whatever you let u be and dv pay the consequence, the integrand doesn't have to be involving all that stuff. There could be some coefficient missing. With integration by parts, I want this integrand to be actually a product of both those things. All right, so I messed up, confusing composition with multiplication. I'll fix my mistake. What do you think? Just say something.
Yes.
Are you going to be able to integrate sine?
Perfect question. Eric's saying this. When I write my separation of UD in such a fashion, can you appreciate it's relatively nasty to anti-differentiate that? Did you guys see my point? And so I think for that reason, I probably would abandon this approach. So here's an honest question. If I swap them, I want a yes or no answer. Is that a piece of cake to differentiate? I shouldn't say piece of cake. I take that back. Is that relatively easy to differentiate? Excuse me. Yeah, I
It's
think
easy
it is.
enough.
Yes or no? Is that easy to anti-differentiate?
Yes.
So why not give it a shot? And if I differentiate over on the left, doesn't that give me 1 over x cosine natural log of x? And doesn't v now become 1/2 x squared? Now, in using my integration by parts formula, I think that suggests that the original integral is a product of my u and v. Minus the integral involving my v du, which actually, is it a 1/2? Is that an x cosine natural log of x dx?
X squared.
Oh, you're right, it is an x squared, but I multiplied it by du. So everybody, my whole point is using my integration by parts formula, look at what I've just accomplished. I've taken what I think is a relatively nasty looking integral and replaced it with an expression involving another integral that's a piece of cake to evaluate, right?
No.
Maybe no, why not? You know what? You're right. I messed up. I think the next integral over here has the same level of complexity as the original one does, and I don't think it really helps. Any suggestions?
So we use
Integrate it again, then plug in what you got.
Maybe let's do it again. Let's give it a shot.
Mm.
I think it's a good suggestion. So you guys mind if I come over here? This time around, I'm going to let my new u be cosine natural log of x.
Those,
My new dv is going to be my x dx.
isn't that just going to do the same thing just that you just did? I mean, it's just going to...
Yeah, it does.
So-
And I'll cycle back to another integral involving this piece, and maybe I can solve that equation using my math D skills. Trust
No,
me.
I-
Trust me. No, I said maybe because you haven't seen it yet, but definitely. Okay. So, here. Doesn't this mean that du is equal to 1 over x, actually, sorry, a negative 1 over x, sine natural log of x dx? And v is going to be 1/2 x squared. Ah, but that tells me that my original integral, sorry, I misspoke. I didn't misspeak, I miswrote. That means my original integral can be expressed as my 1/2 x squared sine natural log of x minus 1/2 times my UV. Wouldn't that give me a minus 1/2 times 1/2 x squared? Cosine natural log of x. Minus the integral involving this product. Oh, but don't forget, I got a factor of negative 1/2. So I guess it's going to be plus 1/2 times the integral involving v du. But wouldn't that be a positive 1/4? Integral of x, I miswrote again. I said times the integral of x sine natural log of x. You said negative. Did I commit a sign error? No, I think everything's fine.
You can divide that integral on both sides now?
I hate to say divide both sides by it because it's an algebraic expression. How about subtracting just both sides? How about putting on some special mathematical glasses? I'm going to make a substitution in my head. Everything you see in red, call it z. And everything else you see in black, treat as a constant. Is this not truly a linear equation in z? And since it's a linear equation in z, let me just bring all the terms involved in the variable z to the left-hand side, all the terms not involved in the variable z to the right-hand side, but that's just simply going to give me 3/4 of my z. Being equal to everything else you see in black.
Can you explain to me where you got the 1/4 from above that?
Yes, I can. You know, technically speaking, you're right. It really shouldn't be there. I really should have had minus the integral involving v du, which means I got a minus 1/2 sitting up front, isn't there? There's a minus 1/2 sitting up front, but don't forget, there's another negative 1/2 being distributed in. That gives you a positive 1/4. Oh, by the way, since I removed all the integrals from the right-hand side of equal sign, do you guys mind if I make this official? Oh, notice something else. I never answered the question. I haven't told you what the integral involving all that red stuff is, so why don't I just, with my math D skills, isolate it? And in isolating it, cheapers, you guys, piece of cake. Doesn't just give me a 1/3 x squared. Choose sine natural log of x. Plus cosine natural log of x.
That's the original.
As long as I'm correct, it's still enough. By the way, I made a little mistake, it seems like, right here. I guess it should be a 4/3 c. Don't you guys agree c plus c is? C minus c is? C times c is? C. C divided by c is? So we're all familiar with the algebra c.
See?
Good, thank you.
Where'd you get 1/3 from?
I multiplied both sides by 4/3.
Okay.
Oh, cancellation with the 4s, left with the 3 downstairs. Just arithmetic gymnastics.
I'm not seeing how you got the red on the right side again.
You know, this came from the following. Look at this 1/2 as being multiplied by everything in my brackets. It's just that with my second assignment of u and v, I misspoke, I said u and v, I meant u and dv. Don't you agree that using integration by parts, I can replace this one integral with the product of u and v, which is right here. Minus the integral involving v du, which is this. So, sir, so far, so good. I merely applied my integration by parts formula to replace this block inside the brackets with this one. It's just now when it distributes the negative 1/2 in, that becomes a negative 1/4. And multiply negative 1/2 times the second term gives you a positive 1/4 on the outside of the term. I just kind of maybe running amok with my arithmetic. Go a
Did you
little fast.
factor the 1/2 x squared out?
Well, I prefer to factor out the 1/4 instead of 1/2 because it's smaller.
Oh, and then I see you put the 2 in.
You can pull out 1/2, it's just that I still got a fraction inside. Anybody else, please attack me. I didn't know this sophisticated example.
Yes, sir. I don't know if this is confusing anyone else, but when you use
Absolutely. You know, technically speaking, I should do that. It's just that I've been using integration by parts so much in my life, I have a tendency not to do that. It's integration by parts, I stick to using DVs, but good point. Maybe I should have called this a W and DZ. Just so you, the reader, can see there's a distinction between applications of integration by parts. Yeah. David?
Yeah, when you're applying a technique to that particular example, or any example in any case, generalizing it, if you start with an example that's pretty complex, as you did there,
Yes.
and you do it twice,
Yes.
and the second time, or 3 times, 4 times, however many times it takes, and then you stop when you have that same example, and then you just apply it.
Yes, and that's why it was kind of awkward, the gentleman sitting next to you. Remember during the break he asked, well, jeepers, how do I know when I apply repeatedly integration by parts formula? And I answered the question by saying, you know, if you got a factor of x to a certain power, and you've got a transcendental factor next to it, differentiating repeatedly gets rid of it. And then I said, there's another technique, another way I see I want to repeat the process. I'll show you after the break, and I finally got there, and the way you said it was nice. You said, relatively nasty integrand, apply integration by parts, gives you another expression involving a different integral, but what's in the integrand's position kind of looks like what it started with. Then maybe applying it one more time, not 3 or 4, just one more time after the first time, I can cycle back to the original integrand, bless you, and hopefully be able to solve that equation for the unknown integral.
Follow-up question. So,
Sure.
is that, I'm noticing you're only using integration by parts with transcendental functions. Are there other functions? Because that works when you take antiderivative and derivative of transcendental functions. But if you're using regular functions, when you have rational functions and all that stuff,
Nah, I
normally
see your
doesn't-
question exactly.
normally doesn't look like itself.
I'm always so nervous whenever I teach a course involving integration techniques like this. Because in chapter 7, section 7.1 through 7.4, I misspoke. 7.1 through 7.5, variety of different integration techniques. And before the second exam, I'm going to assign you guys some homework where you're not told what technique to use, because that'll be like an exam. And you have to make a decision on what technique that you're going to be learning over the next week or two, which one to apply. And for me, integration by parts is always the last to apply, because it involves a bit of work. And so I find it a little awkward that authors of every text I've ever used in teaching calculus gives integration by parts to be the first technique they cover. Now, I think the logic behind that is because I like to say in class, oh, look at the substitution technique. This is just a reverse direction of chain rule. And so I imagine the reason why these authors like to use integration by parts as the first technique is because it undoes the product rule for differentiation. I think that's why.
I don't know, every math class I've ever taken always teaches you the pain in the ass way first, and then teaches you the easy way.
Like with the definition of derivatives,
Yeah.
or Leonard Riemann's some definition of integrals.
Yeah.
Now, I think those two examples I just rattled off are okay because those are the foundations of processes of differentiation respectively.
So could we technically do that one, like x sine of x, if you use sine of x for your u, that way?
Now, I don't know if you remember this, but
Yeah.
Bradley, the first time I answered this question,
Yeah,
I went in the wrong direction.
yeah,
I allowed to do what you just did.
yeah.
It's just that it got worse. It wasn't similar. It got worse because the power of x kept increasing with the subsequent integrals.
So you don't ever get back to your original equation with that one?
Oh, I see.
Yeah.
Okay, now wait a minute. This is a really good question. You guys listen to my words and tell me if I'm not being very clear. Over there, I tried swapping them, generated a whole new expression with the integration by parts formula that involved another integral that had x squared, sine of x, maybe some coefficient up front.
Yeah.
Now if I play integration by parts again, but swap u and dv, what's going to end up happening is this. That's such a good question. I'm glad you brought this up. Applying integration by parts a couple of times, I end up getting the integral of this being equal to some stuff plus the integral of this. Are you just happy there as you were here?
Yeah?
No. Because now when you subtract off the integral from both sides, you get
Oh,
zero.
you have 0.
And if I cycle back like that, Bradley, that's what ended up happening.
Okay.
And so it doesn't answer the question. I don't actually get to evaluate the integral. Here it worked because if you notice the coefficient in front of the red V's, it was not a positive one. It was anything but positive one. And that'll make it work.
So it only works if you have a different coefficient?
Yes, it
Okay.
can't be a positive one coefficient.
Okay.
So if you have, something like a 2 in front of there and subtracting, you get a negative,
That's
integral,
just fine, because
you
that means I
just
get a negative
multiply
integral,
it.
but now when I multiply both sides by negative one, piece of cake, that's what I'm saying, I don't care what the coefficient is,
Gotcha.
positive, negative, as long as it's not positive one. What number am I on, 4? Yes. Yes, sir.
So, when we're looking at, which technique to use, they should be, we should be looking for x raised to the, I don't know, x raised to the 2, or x squared,
A natural number.
yeah, times, just anything else, and then when we integrate it.
See, I disagree. I just think that's one small, very small case scenario in which I probably would apply integration by parts. If I got x to a nice clean natural number power times a transcendental expression, then certainly integration by parts is the technique I use. But I think there are a lot of other reasons why I dive in and use integration by parts. Look at this one. Notice how there's not a nice clean factor of x to some power on the outside. I still think integration by parts applies for this reason. What else can we do? I mean, you can't apply u sub, it doesn't seem to do anything. And since integration by parts technique is the only other technique I've given you, let's just give it a shot. Let's see if it works. I could be wrong. I know I'm saying that in a goofy fashion by saying there's nothing else I can do. But at this stage of the game, because I just started, looking at integration techniques, let's try it. Where are you on a happy scale?
Not very here.
Yeah, I'm still at 0, aren't I? Isn't this begging the question? Because for me to be able to come up with a V, I have to anti-differentiate this particular expression. And that's actually what the original question is. Did you guys see my point? Okay. Well, here's my new question. I want a yes or no answer. Are you able to differentiate that with relative ease?
Yeah.
1 over square root of 1 minus x squared.
I heard a lone voice. He sounded very lonely. Are you all joining him?
Mhm.
Okay.
And for you, x or x.
I agree. That means this one integral can be written as a product of my uv, which in this case is x inverse sine of x. Minus integral of my v du, I want a yes or no response again. Can you handle this? Can you handle that?
Yes.
The answer is yeah.
Yeah.
That's just a quick and easy
U sub.
U sub. Or you're going to allow u to be
Um,
1 minus x
Yeah.
squared. So committing that substitution, I guess that could be x inverse sine of, actually minus. My integral of 1 over u du is just an extra factor of 1/2. And now to anti-differentiate u to the negative 1/2, I'll raise my exponent by 1 to get u to the positive 1/2. But dividing by the new exponent of the positive 1/2 is the same thing as multiplying by its reciprocal. Doesn't that just give me x inverse sine of x? Ooh, forgot my x, didn't I? Minus the radical 1 minus x squared plus c. What do you think? How about number 5? Oh, you know what? Sorry, I guess that was a lousy question. We can already answer that question. How about number 6? No one. Wrong where?
yeah, that's the derivative.
Yeah, that's differentiating natural log of x. It's not anti-differentiating. I guess I can't walk this fast. However, I do think I'm not out of luck. I do think, in applying my integration by parts technique, I can allow you to be nothing more than, I don't know, something I can differentiate. And since you guys think I can differentiate natural log of x, I guess that would be the appropriate choice for you. Because because I can differentiate. I guess VV will have to be everything else. Let's see if it helps. That gives me the product of my u and my v, which in this case is x natural log of x, minus the integral involved in my v du, which is just simply 1. So I guess in the end, I merely have an x natural log of x minus x plus c. I guess I can handle it. You guys are really efficient at getting quiet.
Absorbing.
Have you guys ever done this? I really don't know the answer. And this is not an application of integration by parts. Is everybody familiar with this? Jeepers.
Ln and secant of u plus tangent of u.
So the natural log of the absolute value of secant of x plus tangent of x. Yes? No?
Plus c.
Okay, wait, which one of you are just staring at it? I got an idea. Is that legal, yes or no?
Yes.
It's legal, but there's something really slick about this. Because if you allow me to distribute this multiplication over the addition, don't I get this? Oh man, nobody jumped. Isn't that really slick? Help me with this. What's the derivative of secant of x?
Secant is tangent.
Good. What's the derivative of tangent of x?
Secant squared.
And so I think if I make a quick and easy use of it, allowing u to be what's in the denominator's position, oh, then check this out. du ends up being nothing more than what the heck you see upstairs in the numerator's position. Do you guys not agree? And so committing to this u sub, I'm left with the integral of 1 over u with respect to u, or how about just simply saying the natural log of the absolute value of u, which is this?
So where did you originally get that from? The secant of x plus tangent of x over
Out
secant
of thin
x.
air. Now, I confess, it's a very unnatural looking thing to do.
Yeah.
But you have to appreciate the utility and even the beauty behind it once you see it. Because you really can clearly see now that what you see downstairs has a derivative which is already in the upstairs position. And that's really slick.
How do you feel it when you're supposed to do something like that?
You might not. I think it's a bit tricky. But you know what? In mathematics, it's a trick if you've never seen it before. But once you've seen a trick, it's now called a technique.
Alpha test.
So this isn't integration by parts.
No, I have to confess, I did not apply integration by parts, but in my head, I've got some examples I'd like to discuss. I need this in my next example. So I slipped it in. I just don't know if you've seen it in your past or not.
So that works because you're just essentially multiplying it by 1.
Yes, that's why it's legal. But it's a really slick form of 1 for what I said before. Now everything you see downstairs has this derivative in the upstairs position. That's-
And you can apply like a similar technique for other equations as long as
Yeah, what if I had the integral of cosecant of x? What are you going to multiply top and bottom by? Cosecant of x plus cotangent of x. Now, I admit through the differentiation process, you're going to get a negative sign out there with your u sub for the same idea. Yes? You said the v's? That's all right. I'm the one who's supposed to apologize. I'm so sorry. They're offenses. I'll give you guys a hint. I'm going to apply integration by parts formula. It's just that I apply my integration by parts formula simply because of what you can differentiate and what you can anti-differentiate, just like that on top of your head. What's the one nice choice for my assignments for u and v? I misspoke. For my assignments to u and not v, but dv.
Oh, you can anti-differentiate
You can
secant squared of
anti-differentiate secant
x.
squared with relative
Yeah.
ease. I think that says everything. So let's, you and I give it a shot. Let's go ahead and, I'm sorry, you guys, am I going off? Well, it stopped anyways, wherever it is, my phone, sorry. So I agree with Bradley. I think we should assign dv to be secant squared of x. U to be everything else. So the du is, well, you know what? It's easy to do. I can differentiate it with relative ease. And v is equal to, oh, that's easy as well, as suggested. Now, in applying my integration by parts formula, I think that tells me that the integral of secant cubed of x with respect to x is equal to the product of my uv minus the integral of my v du. Now, I just want an honest answer. Is that an absolute piece of cake to evaluate?
No.
I agree with that. I think it's relatively nasty. What do you want me to do?
Well, when you say relatively nasty, does that mean it's undoable or?
I think it's just as nasty as the original question.
It's undoable?
Well, if the relative nastiness is the same for the original, what I have in here as an integrand, or as an integral, then what do you think I should do? Swap things. I agree. Now, when you said swap things, you might be thinking of a different type of swapping to me. I was thinking swapping out tangent squared of x with you guys.
1 plus, 1 minus cosine.
Secant squared.
Thank you, thank you, thank you, thank you, thank you. Do you think this is going to help? Applying the Pythagorean identity, the second one. Do you think this is going to help? Play some chess. Look ahead.
Yes.
Yeah, because,
It's turns to secant cubed.
yeah, I get an integral involving secant cubed of x. Oh, but shoot, the second integral involves,
Secant x.
well, that's why I took a break for a moment in my head. I knew I needed that. I didn't know if you've seen it. Let's play the game. Let's rewrite this one single integral as a difference of two other integrals. This thing can be this. And everybody, I'm not trying to trick you. I really did make a mistake. Secant of x times secant squared of x is
Secant cubed
secant
of
cubed of
x.
x, not secant squared, as we discussed a moment ago. And now, in adding this integral to both sides, I get 2 times the integral of secant cubed of x with respect to x is equal to my secant of x tangent of x. Is that plus the integral of secant of x with respect to x?
Distribute the negative.
I distributed. And now let me evaluate that integral and divide both sides by 2. And I see the integral that I started off with is nothing more than 1/2 times the secant of x, tangent of x. I don't know what that is. Is that over here? So I get a plus natural log of the absolute value of the secant of x plus tangent of x plus theta. It's there. And if you guys are okay with this, can I use my colored red pen to cheat so I can beat that clock? Can I have this as example, please? I think the only thing changing is now I got balance. And I can evaluate these bounds.
It's a lot of evaluation.
But you know the numbers so darn well. Do you guys agree?
You missed a row of
Oh,
bounds.
thank you, I did. I missed a lot, didn't I? I fixed it.
Oh, you missed one more.
Where? Ah, jeepers. It still saved me time. Oh, but now it's time to evaluate. I guess that gives me a 1/2 times, that was a stall saying, you shouldn't be stalling. You guys, come on.
Root 2 times 1 plus ln of root 2 plus 1. Minus whatever
my
that is.
1/2 times. You guys are killing me. All right, what's the cosine of pi 6? It's the x coordinate. It's the big one. Root 3 over 2, so the reciprocal of that is.
2 over root 3. Rationalize the denominator.
Oh, I won't have to, trust me, I do it in my head.
Okay. Times that.
Thank you. Is that plus the natural log of the sum of these? Oh, I forgot my parentheses. But does that give me 1/2 times root 2 plus natural log of 1 plus root 2? Is that minus 2/3? No, it's not. It's minus 1 over 3. Minus the natural log of 3 over root 3. Or can we write this differently? Guys, can we write this differently?
Yes.
Anybody?
1/2 or instead of 6.
6 times.
Natural something.
3 root 2
Okay.
minus 1 plus 3. Now, am I all alone? Thanks. Natural log of this ratio. Doesn't that look prettier? Oh, you're right. Maybe I can pull out a factor 3. It does work out nicely that way, doesn't it? I think it's nice. It said minus 2/3. Where is that? Well, if I pull out a 3, there wasn't one there, so I put it back in. I pulled out a 1/3 here, but there wasn't one, so I put it back in. But I did pull out a 1/3 here and got my negative there. And I just combined these two logarithms into a single log. You guys, that was so much fun. Can we do it again? Speed reading course to integration by parts technique. Oh, hold it, hold it. I made a mistake. Watch. Differentiating?
X squared.
Thank you. My apologies. Does that give me as 3 secant cubed x times tangent squared x? All right, I'll stop writing. Happy? No, you're not happy. I'm not either. Because I think my next step is to rewrite this as secant squared of x minus 1. Distribute this in. Separate integrals. I got one involving secant to the 5th. Bring it over here. That's beautiful. But the second one involves the secant cubed. Oh, shoot. Now I got to go through all the work I just did erasing the board. Did you guys see my point? But at least you can appreciate the process of just cycling over and over again. And if I knew the integral of secant cubed just like that, I can slam it in. So if you guys don't mind, this is too much work. I'm not going to finish the question. Do you think the same thing applies here? Yeah, I do too. I think using integration by parts, I can actually solve this integral involving secant to the 7th, but it's going to involve another integral involving secant to the 5th, which involves an integral involving secant cubed, which we already evaluated. But you guys see a pattern happening here? I'm duplicating the same process over and over again. So how about saying this? Maybe not an easier way, but maybe just doing it for any power n, as long as it's odd. I've got 10 minutes. I can do this. I think I can do this. You guys, I seriously don't know where I'm going with this. I have no idea if your author has this in the book.
Google it.
You guys are able to see what's on the screen now? In the back of the book, he refers to reduction formulas for trigonometric. He didn't mean that. He meant reduction formulas for trigonometric integrals. And notice how there's one right here involving secant to the n power. Can you guys see that? Because I can't. It's too blurry for me.
Yeah, I can see it.
You can see it. And he gives you a little nifty little formula. So to answer my question, look how fast it is. I plug 7 in for n. I may have to apply it a few times, but I can keep doing it over and over again. So, where do you think this formula came from? With everything I just said, where do you think that formula came from? Thank you. And applying. But I've got 9 minutes left. Do you mind if I do it? I've proved to you this reduction formula holds. And in proving this reduction formula holds, I've lost my black pen already. Cheekers. Didn't you see it? Oh, there it is, right in the middle. Then I think, if I'm going to value this integral right here, secant to the nth power of x with respect to x, you guys all do all the work, you sit back, relax, and let me play. I'm going to allow you to be, not sure, but I'm pretty sure I know what BV is. I want that to be, how about 2 factors secant? Because I can anti-differentiate that piece of cake. And I guess you will be, well, everything else. Paying the consequence of my actions. I guess that necessarily implies that a du is going to be equal to n minus 2 times the secant of x raised to 1 less power, times the derivative of secant of x, which is secant of x tangent of x. And I suppose that means v is going to be just a single factor of the tangent of x. Now, in applying my integration by parts formula, that suggests that this original integral can be expressed as a product of my u and my v, which I guess in this case is just simply tangent of x, times the secant of x raised to the n